Good afternoon, everybody. My name is Seshu Ajjarapuwa. I run the applied AI team at Google DeepMind. My journey with DeepMind has started over a decade ago, which I'll weave into it. Topic today is agents and innovation at DeepMind. We've been talking about agents for a couple of years. I firmly believe that we are in the agents era. It's not something that's coming, we're here. And I worked in this region for about 6 years, from 2006 to 12, still part of Google. When I moved back to the Mountain View office, I've joined the Google's M&A team, and I had the good fortune to work on DeepMind acquisition about 13 years ago. So I kind of, understood what DeepMind did pre-acquisition, post-acquisition. About 6 years ago, I joined the DeepMind team to start an applied AI team on the heels of their innovations in AlphaGo, AlphaStar, AlphaFold. We felt like the time was ready to put DeepMind's research in the real world. While this agent is a new buzzword, it seems like DeepMind has been thinking about agents for a long time. Before I show one of their early agents, I do want to remind that DeepMind's mission has always been around this statement here, even the exact words have changed from time to time. The two tenets of DeepMind's mission is to build it responsibly, which we do, and to benefit humanity. I will cover some of those ways in which we benefit humanity. Talking about agents, DeepMind has always thought about agents as the way to understand the environment in which they operate and to get better. When we made the trek from California to London 13 years ago, one of their first agents was this. I'm sure all of you have seen this video many, many times, and I'm just going to do my voiceover. This is one of the agents that they've showed playing Atari games. It's a game called Breakout. And you can see in after a few iterations, it's not as good. I mean, we could probably pay better than that. 200 episodes, it gets a little bit better. I know it's predicting the ball sometimes. It still misses it. At 400 training episodes, it gets pretty good. I would say pretty, top human level, still not the superhuman level. And it's predicting the ball. It catches most of it. At 600 training episodes, this was think of it as the Move 37 of that time. It's figuring out new techniques called tunneling, and then it puts the ball back, sits back, relaxes, right? And so, I mean, these are the kind of things we've been noticing with these agents in a very limited data for which to operate on. It's just the pixels and the score. And these agents have shown tremendous progress back in those days. And it wasn't just Breakout. The same AI system was surpassing human-level performance on pretty much every single Atari game. And we left London absolutely buzzing with excitement. And we felt like we were on the threshold of an entirely new world. And now it's proving it out to be true after 12 years. And because games were the perfect proving ground to develop and test our algorithms, we kept going. From Atari to somewhat famously mastering the game of Go, to mastering all board games with increasing pace and velocity. And then we added another complexity to the task, playing and winning StarCraft. Now, it's an online strategy game where you play against other human players. And before that, we didn't do that. And we kept going, we kept winning the game of StarCraft. But if we could teach computers how to learn, games felt like they were just the start. So from there, we set our eyes on more important and practical and scientific endeavors of AI. how do we pick these problems to work on? We call it the tree of knowledge. Think of it as any digitized knowledge that human beings have discovered, uncovered, invented, all part of this tree. And what we try to do is think of these root node problems that, with the hubris to think that we can solve those problems, also with the humility to think that we can't do it all. So once we unlock a root node problem, we expect all of you to build on top of that and benefit the humanity. And one of those root node problems is protein folding. And if you were in an earlier session today, Demis talked about AlphaFold a little bit. If you weren't there, think of it as like understanding proteins has been a really difficult endeavor for humans. But they did try to solve many of them, about 180,000 of them, with brute force, trial and error, expensive techniques like X-ray crystallography, and they were all in an open source database called PDB, Protein Data Bank. We got access to the data bank, and then we trained our algorithms on that, for which Demis Hassabis, the CEO and the co-founder of DeepMind, and John Jumper, one of the scientists, they both won the Nobel Prize a couple of years ago. And the implications are obvious with protein folding for drug discovery. But we're also seeing things that we hadn't even thought of, impact in fields like sustainability, agriculture. One of the things that we were really surprised to see was plastic pollution, and which is a critical threat to environment. And supposedly 91% of all plastic produced is single-use, designed to be thrown away right away. AlphaFold is helping researchers make breakthroughs that could help solve this problem. The professors at the University of Portsmouth have discovered, using AlphaFold, enzymes that could break down single-use plastics. That's just like one of the things that AlphaFold is uncovering. There are other like neglected diseases, antibiotic resistance. People have been doing a lot of things with AlphaFold. Now, that's just one of the things we work on in terms of the root node problems. We try to think of root node problems in every aspect of the canonical problems of our time: climate crisis, energy shortage, weather. So we have pretty much our fingerprints in like almost all of these things. I've listed a few things here. Alpha Evolve, a coding agent for algorithm design. This coding agent is a little bit different than the other coding agents that we have, right? This is more, the evolve is a play on the words of Darwin's theory of evolution, the survival of the fittest kind of thing, right? So it's like you solve a coding problem, but in most coding agents, once you solve a problem, that's it. What we try to do is we generate about 10 different solutions. We try to pick the best of it, and then we generate another 10 at that level, and then we keep improving these algorithms till they reach a superhuman level performance. Weather Next. These models are designed for global medium range weather forecasting. Most recently, we announced Weather Next 2, which boasts significantly increased speed and the ability to forecast uncertainty over a period of 2 weeks. If you play it forward, if we can solve and understand weather forecasts for like a year with high precision, there would probably be a lot less human suffering. And there wouldn't be, if there were catastrophic areas, we can move the people out. If there is famine, we can move the grains in. So there are many different ways to think of weather and climate. Alpha Genome is another groundbreaking AI model that's designed to decode the quote unquote like non-coding, the dark matter of the DNA, enabling high resolution predictions of genetic misfirings. And I can go on and on of many other things that we have in this like scientific fields. So we heavily invest in these canonical problems of our time. Specifically with respect to Alpha Genome, by analyzing up to like 1 million base pairs in the genetic code simultaneously, it achieves a state-of-the-art performance across diverse genomic tasks, accelerating the identification of disease causes and then development of new treatments. I'm going to pivot a little bit to here and now. These are all the bets that we have for the long term, and it will take years for us to really have palpable impact in society. We embody the same root node problem concepts with our development of the Gemini models. It has always been multi-model, so that's one of the things we always believed as a root node problem for a universal agent to be multi-model. We wanted to have advanced reasoning. We want these agents to be improving themselves. Like self-improvement has always been a research area for us. Most recently, we're going to talk a little bit more about this in the next session, but we launched the Gemini 3.1 Pro preview, our smartest model to date, and we have a whole lineup of Gemini models. I can't cover the entire gamut of the models we have. I mean, we have models to the left, like the ultra models that'll go and win a math Olympiad. And we'll have smaller models like Nano that sits on your devices. And we have open source models. We have many different models, but these three models get us like a fair share of the workloads. The 3.1 Pro, best for very complex tasks. The 3.0 Flash, in terms of the efficient frontiers, it's a remarkable performance for speed and cost. And 3.1 Flashlight is our like cheapest model, but it's best for scale deployment. And most use cases can be solved within these three. Beyond Gemini, we have a plethora of models in the media generation space. And we see all of these coming together, the diffusion models and the transformer models and all that. And for these models, we have image, video, music, speech, all these different models. The quality is one piece, which we try to get it. But our focus is on the needs of professionals and creatives, not just consumers. That gives us an edge on marketing and advertising applications. Let's look at VO 3.1. I mean, there are many different ways to generate a video out of VO 3.1. One of them is you can give like an image and you can give a background and it can generate a video. Right. Similarly for Lyria, if you haven't tried it, I would highly encourage you to try it. High fidelity music styles, customizable for your brand.
Midnight in the town, the neons popping, headlights flashing, ain't no stopping, rolling through the flats, got the system knocking, block is hot.
This is all generated by Lyria 3, just with a single prompt. Chut 3 is our voice cloning model. And beyond that, last week we announced several other models. Gemma 4 is our family of highly capable open weights model with, I think, 256K context window, the largest of any open source model, and natively multi-modal for vision and audio, heavily optimized for edge devices, and mobile and secure enterprise infrastructure. So I think, we really are giving the best performance for these size of the models with Gemma 4. Gemma 3.1 Flash Live is Google's fastest audio-to-audio model, specifically optimized for your real-time, voice-first AI applications. It has superior acoustic nuance like detection, like pitch, pace, like hesitation, like sentiment, which are very important for natural conversations. Lyria 3 is our flagship music generation model, which can produce high-quality stereo audio with complex structural coherence, reliably generating full songs, like up to 5 minutes, I think, with synchronized vocals and verses and choruses and bridges, and it's kind of a very professional sounding like audio model. Gemini Deep Research Agent, powered by 3.1 Pro, automates heavy duty research by independently planning, searching, identifying knowledge gaps, and iterating on its queries over several minutes. And Genie 3 is, I'm going to talk a little bit more about Genie 3 when we talk about agents and environments. It's our advanced world model that generates interactive, playable 3D environments at 720p that you can navigate with the keyboard just like any other game. And finally, robotics 1.6 model. I'll also show a video about how we're thinking about general purpose robots. With all of these, all these models are being deployed within the Google ecosystem. We have about 7 products with 2 billion users each. We have about 15 products with 500 million user reach. We have a product or two reaching 3 billion user reach. So any models we develop, think of the mission statement, building responsibly. Not only do we have to do it for the sake of humanity, we also have to do it for our business. So all these models, we can't just build a crappy model and throw it over the wall. So we put our models through our products in various different contexts, different surfaces, different use cases. This really helps us understand our model's performance and model losses through a diverse set of use cases. So this is the type of feedback loop that we truly believe is the important differentiator for Google, because we have many surfaces. We are like a full stack company. We develop our own TPUs. We have our infrastructure. We have our products. We have our agents workspace. So all of this gives us the feedback and the evaluations that are truly necessary to improve the models, driving even more adoption and even more feedback. In that, it becomes a very virtuous cycle of advancing technology. Now, agents is like an area that's been front and center. And I said, we've always thought about agents. So I've decided to take 2 different tacks at agents. Agents from a long-term thinking in terms of like, what are the kind of agents that we think that will advance our pursuit of AGI? And then what kind of agents can you build today? I won't spend too much time on the second half. I'll show you a couple of agents that we built for our customers. But I do want to take a little bit of time to talk about how we think about agents. Because we are entering this like new era for enterprises, powered by the potential of agents. If we take a detour back to the world of gaming, which is our heritage, we can learn a lot about the potential these agents offer and what it takes to unlock this, and even how we learn in one domain, like a game of Breakout, translates into a game of Go, or like, other things, and then eventually to robotics and to self-driving cars. First, I think it's helpful to define what an agent is. I mean, we think an agent is an entity that possesses some intellect, and it looks around its environment, and it perceives what it is, which is where our multimodal understanding capabilities come, and takes autonomous actions to achieve a goal. And when we say autonomous actions, it doesn't mean like, risky actions. And I think initially there'll be a human in the loop. Once you gain enough confidence, you take the human in the loop out, which is what we did in our self-driving cars, which I will talk about it in a minute. Now, agents, like I said, have been a part of our thinking from day one, but some of our current agents are the natural outgrowth of our early work at DeepMind in gaming, right? So if you can look at the agents that we built, like the Atari agent, the one that played Minecraft and StarCraft and all that. What's the problem with these agents is that, for example, if you take StarCraft 2 as an example, Alpha Star's performance degrades and some with regressions when there is a new software patch was added to the game, right? So in that, they're not like learning ones. They're a little bit static. We don't want to train a model for every new patch that these gaming developers like applies. So generalization also means potentially opening the possibility of using these agents in development when the game is constantly changing. And you just want the agent still to be a helpful assistant under changing layouts, new features, new capabilities. And let me show you one of the agents that we built called SEMA2. This is kind of think of it as a research prototype, an agent that plays and it reasons in the world in which it operates, and then it's probably like a minute and a half.
This isn't a person playing a video game. It's SEMA2, our most capable AI agent for virtual worlds. Worlds that are complex, responsive, and ever-changing, just like ours. Unlike earlier models, SEMA2 goes beyond simple actions to navigate and complete difficult, multi-step tasks. It understands multimodal prompts. And if you ask, Sima 2 will explain what it can see and what it plans to do next. Sima 2 can learn, reason, and improve by playing on its own, developing new skills and abilities without any human input. And the more Sima 2 plays, the better it becomes, taking what it learns in one virtual world and applying it to the next, and the next, and the next, even if it's never seen them before. Sima 2, not just a milestone for training agents in virtual worlds, but a step towards creating AI that can help with any task, anywhere, including, one day, in the real world.
So for Seema to be a general agent, it needs to play in the same way as we humans do. We only have access to the pixels, we can see what's on the screen, and we use a keyboard and a mouse. We don't have special source code access when you play a video game, no special API key, just the general UI that you see. And that's how we want these agents to play. And beyond simple instruction following, it can answer the user's questions. You can ask, where are you? So you can converse with it with the keyboard, right? So they do look around just like we do. Can you go check out those egg-shaped objects? So they can go walk towards that. And how do you control these agents in this environment, moving beyond, like I said, simple instruction following? What that brings us to, these are the kind of agents we envision that will tell us in a very low-risk environment, right? Just like the Atari games we played, you learn from that, and then you slowly deploy them in the real world. And those are the kind of agents we think of for the longer-term development of AGI. Now let's talk about the environments in which these agents are deployed. For that, we leverage world models, right? A world model is a system that can simulate, like on the fly, the dynamics of an environment, right? If I'm deployed into this room, if I turn this way, I should see all these tables. Those have to be generated on the fly. If I turn around this way, if I go down the stage, so all these things have to be, super fast. The dynamics of an environment have to be simulated. So let's look at Genie 3. This is a little longer video, 2-minute
What you're
video.
seeing are
I
not
hope it's
games
worth your
or
time.
videos. They're worlds. Each one of these is an interactive environment generated by Genie 3, a new frontier for world models. With Genie 3, you can use natural language to generate a variety of worlds and explore them interactively, all with a single text prompt. Let's see what it's like to spend some time in a world. Genie 3 has real-time interactivity, meaning that the environment reacts to your movements and actions. You're not walking through a pre-built simulation. Everything you see here is being generated live as you explore it. And Genie 3 has world memory. That's why environments like this one stay consistent. World memory even carries over into your actions. For example, when I'm painting on this wall, my actions persist. I can look away and generate other parts of the world.
I think you get the idea.
what-
I think in the interest of time, memory is an important aspect, right? Now you paint, you turn around, and you come back, it has to be there. Navigatable environments is an important aspect if we really want to build robotics and self-driving cars, right? And the research flywheel here is the Genie and the Seema, the flywheel. The way it works is, we train an agent in a simulated environment, right? So we're safely training the agent within the world that we just created, and it learns from diverse scenarios without any real-world constraints, right? Then we deploy the agent, and as it acts, it gathers new information, new experience data in an environment. We take that back, and then with the collected data, we improve the simulated world to make the agents even better, more capable, right? So this is how we keep improving these agents, but at some point this has to stop and then put it in the real world, right? So this is all theoretical and research focused. But how do we apply this flywheel practically? A great example is our collaboration with Waymo. For those of you that are unfamiliar with Waymo, it's our self-driving initiative. It's a 15-year-old initiative. And the Waymo autonomous driver, it's an agent. It's a driving agent. It performs tasks autonomously on behalf of the passengers. To train, the driver, the autonomous driver, completes many millions of miles on the road, right? So this is highly expensive. Under the supervision of a human driver, we use that data. So with things like Genie and worlds that we can simulate, you can cut that like manual driving part a lot less. So what we did with Genie was we created a self-driving foundational model. We generate synchronized photorealistic camera imagery and then high fidelity 3D LiDAR data. And then we deploy conditions like a driving through a tornado, or like, look at the example that we have there. When do you see that when you're driving? Very rarely. So you'd have to drive like millions of miles to find some drunk driver like driving across the street, or like a deer running through the street. So we can simulate these things and learn from them. Wildlife encounters. I once had a deer hit 30 years ago. Extreme weather, aggressive drivers. You can simulate all these things without like really spending time on the road. And the what if counterfactuals, they alert our trajectories, and then they teach like better ways to drive, better ways to stop, anticipate. So this is the loop that I've been talking about, and this is the first real world use case for Genie that we did internally. Now you can imagine this type of feedback being very important in robotics as well. I may have maybe one more video after this. Here you see our like latest Gemini robotics model running on a plant floor, Boston Dynamics hardware in a factory setting, right? It's a minute and a half video. So our approach to robotics, if you haven't been following our robotics, is we're not interested in building bespoke robotics that require enormous amount of training. We want robots to just learn like human beings, like how to tie a shoelace, how to pack a sandwich in a Ziploc bag, these kind of things. And we want to bring in the Gemini's world understanding to the robotics platform, and then use the same transformers kind of architecture to thinking you got voice input, you got like multimodal, all that stuff to spit out robotics tokens, which are kind of actions and angles and all that. So that unification is happening pretty solidly. So we're very optimistic about being able to support general purpose robots in time. Again, this is one of those things that will take time. I'd like to end with here and now. I've given you a glimpse into where the future could be with these virtual agents we can build, worlds we can create, robots we can deploy. So I want to talk about enterprise applications, which is probably all of you are probably thinking every single minute. So let's talk through an agent. Again, is an intelligent being. It takes action. It built to get things done for you. So far, the agents have been, we're mostly talking to the agents. We want to think of, this is not my word, somebody did it and I like the phrasing. We want to task the agents, not just talk to them. So how do you task them? And when do you gain the confidence that they'll take the actions? I mean, even simple things like buying a movie ticket or making a hotel reservation, or customer service, all these kind of things, right? So they have to put together a plan. They have to pick the right tools. They have to have access to the relevant data, wherever the data may sit, and then they have to execute tasks on your behalf. That's what an agent is in our thinking. Well, there are many different types of agents you can build. There are role-specific agents that you can build, like a coding agent that just does coding. Doesn't matter whether you're in financial services or gaming or retail. You're coding, it's a coding agent. Similarly, marketing, a data scientist. But then there are domain-specific agents, like, if you're a quick serve restaurant, like a fast food chain, right? You want the agent to know that based on your license plate or something, what you ordered last week, and maybe it should offer you. Do you just want to order the same thing? Or let's say maybe you're a vegan, and it'll only give you the vegan menu. So there are many domain-specific agents that we can build. And there are thousands of partner-built agents that are available, and we maintain a library of them that you could use. So there are many different ways to do this. And last week, we announced a bunch of new things for this agentic era of, we announced an ADK, an agent developer kit. We had an agent getaway. We have simulators. We have observability tools. We have optimizing tools. We have a ton of tools. So based on that, all your employees would have like many different ways to do these things. Like some people may not have any coding experience. So we offer for them, natural language into an agent by, called agent through agent developer, right? Or you can use an agent builder if you are familiar with coding and a little bit of, low code kind of ways to build, and a pro code. If you're like really a professional, we have, Gemini CLI, we have agent development kit. So we have tools for every single type of your employee. Now, I will talk about 2 tools that we built, and then I'll wrap it up. One of the tools we built was for UK government. Usually, supposedly, it takes like 6 weeks to approve like a housing change plan, right? We announced a partnership with the UK government. We built an application review agent that leverages Gemini's multimodal capabilities, document understanding, photos, and geographical data. It extracts the data and provides a clear decision-making support to bureaucrats, so there is still human in the loop as they review the applications. And one day, we probably don't need a human in the loop. Another agent we built, this is the last video I think I have, we worked with Citi to build a financial advisor agent. And its capability of, it knows about the customer, it's available around the clock. You can democratize financial advisory. Maybe only high net worth individuals get it. Maybe everybody can use it now. And it can give you advice based on current events. This was powered by Gemini native audio that I talked about. And we used a Genie model to render the avatar that you're going to see.
Hey, Sky.
Hi, Jackson. Thanks for logging in. I see you clicked on the notification about your maturing certificate of deposit. How can I help you today?
Thanks. Yes, it's great to see my balance, but what are my options here?
Your bank CD matures next week. Great news. You have a few options to consider. Here's what's available to you. Option 1, renew at 6 months at 4.85%.
You get the idea, right? So it knows about you. It knows all your investment. It knows what's happening in the market. It knows your risk profile. It can really advise you without waiting like hours and hours on a phone call or, right? So I think my call for action is now it's your turn to supercharge your business with all the tools we're giving, the technology we're giving, the agents we are like showcasing. Enterprises often feel like they have to choose. Do we fix the core business and like squeeze out like all the efficiencies we can? Or do we build the next big thing? We believe in the AI era, you don't have to pause one to do the other. You create a continuous cycle of growth. It works like an infinity loop. On one side, you transform the core with all the tools we built. You use proven agents to eliminate operational drag today, minimize waste. This captures the immediate value and efficiency you need to stay competitive. And that efficiency and the cost savings fuels the other side. Reinvent your businesses, create new opportunities, develop new use cases. It's a self-propelling engine. You transform to compete and you innovate to win. And you do them both at the same time. With that, thank you all. I can't wait to see what you're all going to build.